Welcome guys, I'm Dr. Avitech, and in this video we're going to be solving this very problem. So the first thing we want to do is they've kind of helped us in a way. They've actually told us where to look at, because if you're given this function, the first thing you want to do is to first describe the function analytically. But before then, remember to hit the subscribe button, like this video, and share that across to your course mates. So since they've said we should do this from minus pi to pi, I don't think I should really spend much time doing otherwise. Obviously, none of us have it, so I shouldn't be doing that. But if you look at this function, you might want to say that it's going to be from minus pi over 2 to pi over 2, but that's not true, because if you look at minus pi over 2 to this, function value was 4. But from pi over 2 to the next part, it wasn't 4 anymore. It stayed at 0. So you actually have to be very careful when picking the points to look at, or when choosing your period, or when describing your function. But let's describe this from minus pi. So from minus pi, we have f of x equal, so from minus pi to minus pi over 2, it was 0. It was flat. So it was 0 from minus pi less than x less than minus pi over 2. Then from minus pi over 2 to pi over 2, the value was 4. So it was 4 from minus pi over 2 less than x less than pi over 2. And then it was 0 from pi over 2 to pi. 0 from pi over 2 to pi. So this right here is the analytic description. So let me put commas. Yeah. So the next thing we want to do is to find our coefficients, a naught, a sub n, and b sub n. So a naught is 1 over pi integral from minus pi to pi of f of x dx. But the thing is, our function is not from minus pi. That is to say that no single function value ran from minus pi to pi over 2. So since no single function ran from minus pi over 2, we had minus pi to minus pi over 2, minus pi over 2 to pi over 2, then pi over 2 towards pi. So it means we're going to be splitting this integral to all of this. So we're going to say this will be 1 over pi. We're going to start integral from minus pi to pi over 2 to minus pi over 2, plus integral from minus pi over 2 from minus pi over 2 to pi over 2, plus integral from pi over 2 to pi. So that's how we're going to break it down. And then the f of x dx, f of x dx, f of x dx. Yep. But the thing is, I don't really want to waste much my time. I think if you notice, if you've been following me, when it comes to a naught, I basically do not waste my time. Already, from minus pi to minus pi over 2, it was 0. So this should be 0. Let's save ourselves the stress. This would also be 0, because from pi over 2 to pi, it was 0. So the only thing left is just this one. It is just this guy, just this one. Now, remember that in the previous videos, I said that integrals are asking you to find area, right? So let's find the area of this very shape. This is a rectangle. It's a rectangle. So life is kind of easy because it's a rectangle. So this is 1 over pi times the formula for area of a rectangle is length times breadth. So this is 1 over pi times, what is the length? It depends on where you want to choose as the length. But the length is how high the rectangle is, and that's 4. So this is 4 times, what is the breadth? That's this guy right here. So from this part to this part will be pi. Please take note, from minus pi over 2 to pi over 2, the distance here is actually pi. It's just like saying the distance from minus half to half. That's going to be 1. So you could do this by saying, let me just show you. This will become pi over 2 minus pi over 2. So this is pi over 2 plus pi over 2. So remember, when you add up 2 halves, you just have pi. So the distance between this is pi. So when pi cancels out pi, this will be 4. So a naught is 4. I don't really want to waste my time doing an integral of that. So I would have done that a little earlier, but I just wanted to explain how to do that. Okay, now let's proceed to find a sub n. Now, a sub n is 1 over pi integral from, since we know that all of these guys will be 0, let me only be picking the middle one. Minus pi over 2 to pi over 2 of f of x cosine of nx dx. So that's what my a sub n will be. So this is 1 over pi integral from minus pi over 2 to pi over 2. Now f of x here was 4. So this will be 4 cos nx dx. Please remember that the ability of, or should I say the ability? Yeah, if you have the ability to know what's going to happen to a function at a particular point in time, it's very important to saving you the stress and time-consuming nature of Fourier series, because you have to agree with me that it's time-consuming. So, if you notice, I skipped this step here. I skipped this step here because I already know what this will be. Well, let's proceed. Now, this 4 can come outside. So, let me bring out the 4 is a constant. So, this is 4 over pi integral from minus pi over 2 to pi over 2. What will be remaining is cos nx dx. Okay, so this is 4 over pi. Now, let's integrate cosine. If you integrate cosine, you have sine. So, this will be sine nx divided by this angle nx. Differentiate the angle nx, you have n. And then you put in your limits. Minus pi over 2 to pi over 2. All right. Now, the n here, this n here is a constant. So, bring it out. So, this will be 4 over n pi. Then we have sine. Now, let's put in our limits. So, this is n. X will become pi over 2. So, this will be n pi over 2. Then minus sine. Let us put in this minus. So, this will then become minus n pi over 2. Yup, that's what it's going to be. Now, sine is an odd function. Sine is an odd function. Since sine is an odd function, the minus comes outside. I think after this video, I'm going to treat, very soon, I'm going to treat even on odd functions. So sine is an odd function. So the minus will come outside to make this minus to make it a plus. So this will be 4 over n pi. Then we have sine n pi over 2 plus sine n pi over 2. Now, obviously, this is a double. This is a double. So this will be 4 over n pi. And then we're going to be having times 2 sine n pi over 2. Yep. Please take note, this is inseparable. You can't separate. So these two cannot cancel out these two. You can't separate that. So 4 times 2 will give me 8. So this is 8 over n pi sine n pi over 2. Now, what you want to do at this point is you want to see if you can find an expression for this. You want to see if you can actually find a way to get some special values for this. So let's work it out. Let's see. We know that sine n pi is equal to 0. We've been able to find that out from previous equations. That sine n pi is equal to 0. But what about sine n pi over 2? So let us start figuring that out. Let's start figuring out the behavior of sine n pi over 2. First of all, since n pi is 0, this is over 2, right? Now, I kind of know that for me to divide by 2, for me to divide this, for this division, for me to divide by 2 and the 2 goes away, it means this n has to be even. Because if there's an even number here, that even number will definitely be cancelled by 2. So if that even number is cancelled by 2, I would then be having sine of pi. Sine of some number multiplied by pi. So that would be 0. Because I know that sine multiplied by some number with pi will give me 0. So that means whenever n is even, sine n pi over 2 will definitely be 0. Because if this number n here is even, provided this is even, it will then be divided by these 2. So when that even number divides these 2, we'll then be having a number multiplied by pi. And we know that when a number is multiplied by pi, the sign of that will give us 0. So that's why this will be 0. Now, the next thing is when it is odd, but I feel like there's going to be a change in behavior. Let's start with when n is equal to 1. When n is equal to 1. So when n is equal to 1, sine pi over 2, because 1 times pi is pi. So sine 1 over 2, no, not 1, pi over 2 is 1. Sine n pi over 2 is equal to 1. Please take note that sine pi over 2 is actually sine 180 degrees over 2. So that's sine 90, and sine 90 is 1. Sine 90 is 1. So that's why I said sine n pi over 2 will be 1 if n is equal to 1. Now, the good thing is, since I already know this, instead of me stressing myself to find, oh, what other part would sine n pi over 2 be equal to 1? What other number would it be? I know that. This is why it's interesting for you to remember so many things in trigonometry. In trigonometry, we have 4 quadrants. So a quadrant behaves the same way in its multiples. Let me say that again. We have what we call the quadrants. So yeah, this value, what we call the quadrants. And they are 4 in number. So this very quadrant here holds 360 degrees. Now, the behavior of the trig ratios in this quadrant is the same in multiples of this same quadrant. So a multiple of this is going to be what? 720, because 360 times 2 will give me 720. So when I say multiples of it, I mean when you keep on multiplying this by some number. So you say 360 times 2, 720. 360 times 3 should be 1080. So the behavior of the trig ratios in multiples of the quadrants is still the same with n is 360. Now, why did I say this? I said this because here we have 4 quadrants. Here we have 8 quadrants. Here we have 16. Since we're taking multiples, don't get it wrong. Since we're taking multiples. Now, what does this mean? This means that there's always an addition of 4. Meaning, if I add 4 to a particular quadrant, the value will not even change. So what it means is, if n is equal to 1 here, and it gave me my sine n pi over 2 was 1, that means when n is equal to 5, it will still be the same thing, because what I did was to add 4 to the 1 to get 5. Also, if I should add 4 to this very 5, I'm still going to get 9. The value will still be the same when it's 9, because I am adding multiples of the quadrant. So since we have these 4 quadrants, if I keep on adding 4 to each of these numbers, my value will still be the same, because they are all assuming the same position in the quadrant. So you are not really going to change anything. That is why this is going to stay. Provided you keep on adding a constant number 4, your values will still remain the same. So with this, let's go to the next one. So for the next one, if you notice, we're dealing with odd numbers here, but there's no 3. There's no 3 here. There's no 7 here. So that means I think those ones will be behaving much more different. So let's see. I need to wipe this out. Oh, let me explain here. So when n is equal to 3, so this will be sine 3 pi over 2. So this will be sine 3 times 180 degrees over 2. This will become sine 3 times 180 is 540. 540 divided by 2 is 270. Sine 270 degrees is minus 1. Sine 270 degrees is minus 1. So this is when n is equal to what? When n is equal to what? 3. Let me clean this out. So when n is equal to 3, our sine n pi over 2 is minus 1. Now, how do we then know other values of n that will give me the same minus 1? I will start adding 4 to it. So 3 plus 4, 7. 7 plus 4, 11. Just like that. So it's actually very, very sweet. So that's how we get these values. So let's do something here. Yeah, something can be done. So let's do something. Yeah, I don't want to wipe that out. Okay. So now I'm going to say from everything that I've done here, we know that for our a sub n, yeah, I can just say that. For a sub n, so a sub n is 0. Let me do it like this. Hold on. So a sub n, to make it fine. So a sub n will be 0 when n is even. A sub n will be 0 when n is even. Good. Let's proceed to the next part. Now, we have 159. And we know that this sine n pi over 2 will give us 1. Sine n pi over 2 will give us 1. So if this is our a sub n, if this sine n pi over 2 give us 1, 1 times 8 over n pi is 8 over n pi. So that means our a sub n is 8 over n pi if n is 159, just like that. Then lastly, sine n pi over 2 is minus 1. Minus 1 times 8 over n pi is minus 8 over n pi. And this would happen when n is 3, 7, 11. Just like that. So I think I'm going to leave this. I don't want to touch that, so I'm going to leave it. Now let's find b sub n. So b sub n is 1 over pi integral from minus pi to pi of f of x sine nx dx. So this is 1 over pi integral from, we know that the only useful thing in this whole function is this part. This is the only useful thing in the whole function, because this is 0, so the only useful part is this. So this will become from minus pi over 2 to pi over 2. Then f of x was 4 sine nx dx. Okay, so this is 1 over pi. The 4 is a constant, so it could come outside. So 4 over pi integral from minus pi over 2 to pi over 2 of sine nx dx. So this is 4 over pi. Then, if you should integrate sine, you will get minus cosine nx. Then divide this by n, because you must always divide by the derivative. It's a must. And then you put in your limits, minus pi over 2 to pi over 2. All right. So bring this minus outside. Bring the n outside. So this is minus 4 over n pi. The all will be left to become cos nx from minus pi over 2 to pi over 2. So now let's put in our limits. Let's put in the limits. So this is minus 4 over n pi cos, put in your limits. This will be n pi over 2 minus, put in the next limit. This will be cosine of minus, because this guy has a minus, so this will be minus n pi over 2. Okay, now we have minus 4 over n pi. Then this is cos of n pi over 2 minus, remember that for cosine, the minus does not come outside. When it's sine, the minus can come outside to make this minus to make it a plus, because this is an odd function. But this minus cannot come outside there because cosine is an even function. So the minus is the same with when it is positive. So this will just remain cos n pi over 2. Now these two things are the same. They're both the same. So since they're both the same, it's just 0, because this minus this will give me 0. So 0 times this will give me 0. So b sub n is 0. So that's b sub n. And finally, we've found all our coefficients. So b sub n is 0, then a sub n is 4. Sorry, a naught is 4. Yeah. So right now, let us find the Fourier series expansion of the function. All right, so we know that f of x is a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sin nx. And the good thing is b sub n is 0. So this will just be 0. Yeah, that's 0. Now, a naught is 4. So this will be 4 over 2 plus. Okay, this is where it gets beautiful. So for this part, the a sub n has different values. It has different values. So these are the different values. Yeah. So what we're going to do is, we're going to start by saying, okay, when n is equal to 1, a sub n is 8 over n pi, right? So this will be, hold on, I need a better way to just write this. Okay, you know what? Let's proceed. The sum from n equal to 1 to infinity of a sub n, where's that? It's 8 over n pi sine n pi over 2 cosine of nx. Yeah, it's looking bulky, but just hold on. It's looking bulky, but just hold on. It's looking bulky, but just hold on. Now this will be 4 over 2, which is just 2. Which is just 2. Then, okay. I'm looking for a better way to write this. I'm looking for a better way to write it. I kind of know what to do, but just a better way to write the whole expression. That's what I'm looking for. Okay. Okay, see what I'll do. Let's proceed. Let's proceed. So what I'll do. 8 over pi is a constant. 8 over pi is a constant. So 8 over pi is a constant. Let me bring that out. So this is 8 over pi. Then the sum from n equal to 1 to infinity. What will be left will become 1 over n. 1 over n sine n pi over 2 cos nx. So this is 2 plus 8 over pi. Now let me open up a bracket. So I'm going to start. Anywhere n is, I'm going to be putting odd numbers because we know that answers only exist for odd numbers, not even, only odd numbers. So when n is 1, when n is 1, what do we have? So this will be 1, this will be 1, because this is 1 over 1. What's the value of this when n is 1? When n is 1, this is 1. So then we have cos x remaining. If you look at this carefully, it looks as if I'm not using this. It looks as if I'm using just this part. So take note of this. It looks as if I'm using only this part. Yeah, it looks as if I'm not using this, I'm using just this. So we have 1 over n, which is 1 over 1. This value here, when n is 1, is 1. So 1 times 1, then cos 1x, which is just cos x. Next part, I would have said 2, but you know 2 is what? 2 is even. So the next part will be 3. So 3 is minus 1. So this will become 1 over 3 times the minus 1. So that's minus 1 over 3. That's minus 1 over 3. And then cos 3x. Just like that. So the next odd number is 5. And when it's 5, it's just plus 1. So this will be 1 over 5 times 1, which is still 1 over 5. So this is plus 1 over 5 cos 5x. If you notice, it now follows a pattern. So the next one will be minus 1 over 7 cos 7x. Next one will be plus 1 over 9 cos 9x. Next one will be minus 1 over 11 cos 11x. But the thing is, you cannot go on to infinity, so you must stop somewhere. So put then you close it up. So this will be the answer to our equation. So this is the Fourier series expansion. And with this, we're done with this very video. So this will be all. Remember to hit the subscribe button, like this video, and share it across to your classmates. I'll see you in the next one. Bye.